If I may, can I please ask the presenters of the three case studies to come online? This is an opportunity to address any questions that we may have received on the Q&A function. So thank you for joining me. There are quite a few questions. Some are very technical. Where shall we start? Well, let me try. The first question is, what is the temperature of the flue gases from the electrical arc furnace? I think this is for Ori Martin.
Yeah, actually the temperature of waste gas from electrical arc furnace is around 1100, 1200 degrees Celsius at the end of the constil, so at the output of electrical arc furnace. But the fumes goes into the heat recovery steam generator at an average temperature between 450 to 700 degrees Celsius. So from this temperature, we start to recover the heat.
Okay.
450, 700 degrees. This is the answer.
Okay. This is more of a general question, maybe both from Andrea and Sarah. Why do you choose to generate steam if you use heat for district heating or in the RRC? Why not use just steam, a steam turbine directly?
I can answer by Ori Martin's side. Actually, because with this steam, we heat up the temperature of the water of the local district heating. So we produce steam to heat it up the temperature of the water. And we choose to use an ORC turbine, first of all, because it's a smaller plant. The footprint is smaller than a steam turbine. It's not so complicated. It has only 2 stages and not many stages. And also because we have a very variable pressure due to the not continuous operation of the electrical arc furnace, and the ORC turbine can change the electricity production, is very flexible compared with the variation of the pressure from the steam generator.
Thank you, Andrea. Maybe just a second follow-up, well, not follow-up question, just second quick question. There was a question regarding the cooling tower that it's no longer used. Will it be removed?
Okay, the answer is no. First of all, I have to say that to cool down the water temperature of the electrical arc furnace, we are not using the cooling tower, but we use air coolers, so big fans. But this is just a detail. Actually, as I was telling before, the answer is no, for 2 main reasons, I would say. First of all, because the large heat pump is in operation only during the winter time, so for 6 months in 1 year. So the rest of the year we have to send the water to the air coolers, and then also to have a backup just in case the heat pump will be under maintenance or won't work properly. So no, we are not going to remove.
Okay, thank you, Andrea. Maybe a question for Sarah. It's regarding the net efficiency of the ORC in the cement industry by only using air in the condenser side. Is that something that you could possibly answer?
Yes, absolutely. The net efficiency for a cement plant ranges between the 18% and the 24–25%, depending on the air temperature using, in the case of the ACC, the air-cooled condenser. Then it depends on the exhaust gas temperature. That should be on 350 degrees with a flow rate of 50,000 normal metric cube per hour. And then the further factor that influences the efficiency is the ORC turbine size, of course.
Thank you, Sarah. And there were 2 questions regarding the Violi case in Poland, but I see that you're quite efficient and had already answered them online. So for those who are not looking through them, there was a question regarding the COP of the Veolia case, and the answer was the COP of the heat pumps was between 2.7 and 3.5. And then there was a question pertaining to what kind of heat pump was used in Poland. It's a water-to-water heat pump. Glycol is the fluid that's being used in the circulation. So thank you for already answering those questions. Maybe a more general question. I'm not really an expert in heat pumps, but is it possible to have a COP over 3.5? Those who have some experience with.
Well, of course, that depends on the type of the heat pump. But in our project, we haven't achieved more yet, and we don't expect to have more.
Okay, you're absolutely right. There are many different types of heat pumps and applications. A question to Sarah. Which fluid is used in the waste heat boiler? Is it thermal oil too? If yes, what type and which type of waste heat boiler is it?
Concerning the waste heat boiler, so the primary heat exchanger that exchange with the fumes, we usually use the diathermic oil like terminal 66 or terminal 56. And concerning the working fluid, that is the fluid that works in the RC turbines, in the RC systems. That one is usually an hydrocarbon, or can be also a siloxane fluid. Or in case of non-flammable fluids, we can have also refrigerants.
Okay, thank you, Sarah. I'm just looking through the questions again. There was a question for Mr. Pauluk. What is the role of CHP as part of the integrated project you just presented?
Well, CHP is main. The main goal is to provide electricity for the heat pumps. So it is quite closed circuit. And additionally, it heats up the heat from the heat pumps to the temperature with the heat CHP produces. It heats up the heat to the temperature of 85 degrees that we can provide it into district heating, which is the one of high temperature network.
Thank you. Thank you. Yes, an excellent example of system integration. Maybe one final question. I don't know who would be able to answer it, but terminal oil 66 is so expensive. Is it possible to use some other mineral oil?
Usually, we use the terminal 66 for its operating temperatures and performance, and actually, it's the cost of that oil is not so high. Other oils are not. We are studying we are trying to consider also other oils among the possible ones, but at the moment we just use that one.
And since you were on the floor, one more question for you, Sarah. Is the last question on the Q&A. Don't you fancy any scaling issue on the heat exchanger, fumes, thermal oil? Oh, sorry. Do you face any scaling issue on the heat exchanger? My apologies.
Sorry. Any scaling issues on heat exchanger? Actually, we do not produce directly the heat exchanger. We design them, and there are some colleagues that are specifically they are expert in this field, so I can give you an answer later by email. There was also, sorry if I can add something else, A question about the references, our references in cement, steel, and oil and gas from engines. And if you prefer, I can show you quickly some references or send them later by email, as you prefer.
If you have some references, please, yeah, we have a few more minutes before we need to wrap up. So if you have some examples.
Okay. Perfect. Can you see my screen?
Yes.
Okay. So in general, we can say that this is a global view of the reference in TURBODEN. So we have several plants in the R2A-based sector, cement, steel and metal, glass, but also in the oil and gas sector, from recovering the waste heat from engines and also intercombustion engines, and also from the flare gas and gas compressor station for the gas turbine. And also we have we recover heat through the use of gas expander, as you know. Concerning specific references about cement, we have this list of references. So between the most important group with which we worked, we have Holcim, Lafarge Holcim, CRH. We have a plant in Slovakia and also another one. And then we have another one for CRH Group, Euro Cement in Switzerland. Then we have Simco and Holcim again. Concerning the steel and metal, we have different references here too, and we have the most important one in Italy, that is Arbedi. Then we have other references in South Korea, Malaysia, Germany, and Singapore. And the last question was about the oil and gas, specifically from engines, and we have a lot of reference also in this field with plants in Germany, Finland, Italy, Turkey, and Belgium.
Thank you, Sarah. And I believe these slides will be made available online anyways after the webinar. So people will have an opportunity to look at these different reference cases. So I think we've come to the end of the Q&A segment. So thank you again to our presenters for taking the time to present these different case studies and also answering the questions both orally and writing. It's much appreciated. And this is not the end, in fact. This is just a brief overview of the HEATLEAP project and different applications of waste heat recovery. So we're very happy to have this opportunity to hear from 3 very different industries and different countries, learning more about the challenges, but also the opportunities for recovering waste heat.